can find, actually, if you have activated, if you have pressed the thing that I did before, under properties, you'll see a lot of other things available. You see now mass entropy, mass entropy. This is not available unless you checked the activate properties. Okay? So by checking that, you have more information available here. Okay, you can see CV, you can see viscosity, you can see a lot of things. Any questions so far? Is everybody okay? So, it's still not specified because it needs the flow rate. For this problem, does it matter what flow I'm going to have? It really doesn't. So we can just specify any flow we want. We can specify a mass flow or a molar flow, whatever is our choice. So let's put 1 kilogram per hour mass flow. The moment I do that, we get our favorite color when running unison. Green is the color you like. Green means everything is well. And also dark blue here. This becomes dark blue. Okay? And everything in, if you click on the stream, you see the green at the bottom. All right. So we specified the feed stream this way. What do we have next in our process? We have the valve. Well, where's the valve? How about here? If you hover, it tells you what they are. One says valve, sounds like a good thing to click for valve. Click on it, move it to the right of the stream. Okay. Question?
I was just confirming, was it molar flow rate you chose or mass flow rate? That was one.
Mass flow.
Okay, mass flow.
Memory says me right mass flow. Double click on the valve. You can name it if you want. I'll leave it as this. Inlet. If you want to select the stream, and in this case I already have the stream ready, stream 1. I haven't created anything for the outlet. If you give it a name, it will create it for you. So I'll write stream 2. Now, you can specify things in different places. Valves have pressure drop. I can specify a pressure drop. But I can do, what's the pressure drop I will have? It's the difference between 8,000 kilopascal and 1 atmosphere, which is 101.3 kilopascal. Or alternatively, leave it unspecified and click worksheet. So click worksheet. There you see a list of the streams affecting this process. And I can enter the pressure right here. So what the pressure? I want 1 atmosphere. Type 1, and you see here the default is kilopascals. These are the units for SI units. Click the arrow, and you have a choice for different units. Select atmosphere, it will convert it to kilopascals for you. By the way, are you seeing 101.32 or are you seeing something different? You seeing 101.3 instead?
101.3.
That's because I have a different number of significant figures I'm showing. Let me quickly show you how you can change that if you want. You go back to Tools, Preferences, Variables, and here, Formats. And you see mine says 5 significant figures. Yours has 4. If you click Format, and let me see, Format, I click here. Yeah. And change the significant figures to 4. I'll have 4. If I change it to 6, I'll have 6. I'm changing it to 6 now. Okay? So format to select all of them together. You can do one at a time, okay? But if you want to select all of them together, click the format bar on the top. And then click format and change the significant figures you want. So in my case now it will show 101.325 since I changed it to 6 significant figures. And again, I exit with the X. So if I double click now, go back, you see that it will say 101.325. Everybody okay? Anybody needs more time? All right. Notice it actually calculated the temperature. Okay? I'm surprised.
Yeah, that looks That looks wrong.
I'm surprised they gave me. That's not what I have in my notes. Huh.
It only changed 2 degrees.
Yeah. And I'm surprised at the value. In my notes, I should have gotten 464. That's what I expected. I don't know. Okay. Oh, no, it's nitrogen. Yeah, no, I use nitrogen. So, yeah. It's interesting that you see it going higher. For most substances, it would go lower. But, I don't know, did you cover the Joule-Thomson coefficient in your fluids class, in your Thermo 1 class?
Yeah.
Remember, that can change sign. That can be positive or negative. And nitrogen is one of the things that, at these conditions, actually, you get an increase in temperature. Okay, so that's the temperature out. We solve the problem. Notice, we show you the enthalpies. Notice the enthalpies are identical. That's exactly what it did. It solved the equation H at T2 equals H at T1. If we choose a different model, we get different results. Let's choose a SRK instead. How am I going to change the model to a SRK? Who remembers?
5. Oh,
What do I press now?
you have to go to the arrow? Like the inlet arrow?
Where do I go to change the thermodynamic model?
Composition? Oh, no.
We hit the flask, and then hit the flask, then go to fluid package.
That's it. We hit the beaker. Beaker, not flask.
Sorry.
Go to fluid packages, save U, and instead of Frank Robinson, let's choose SRK. X to exit here, return. Ask me if I want to put red light. No reason, say no. And let's see what we got now. 504 degrees. Leave. So the prediction depends on the thermodynamic model that I'm using. Frank Robinson gave us 502, SRK gives us 504. Now, how about if we choose, let's choose an activity coefficient model. So I'll go back to the beaker. For your senior design class, you will be using general and RTL. So let's choose general and RTL. View, let's choose general and RTL. Okay, so I chose general and RTL. And now, no, we're going to say that it's exactly 500 degrees C. And if I were to put 100 significant figures, it would be 500 degrees C. I shouldn't have expanded that much.
Because you made it ideal.
Huh?
It's because you made it ideal.
Okay,
Let's end the class on that.
bingo. Jose got it.
See you on Friday.
Ha ha ha. All right. The reason is, what are you doing?
Class not over?
No.
Oh, it's at 4:40. Oh, damn. No way.
Almost over. I guess time is close to being over.
Wait,
But
it's at 4:45?
yeah. Yeah, but come on, a minute. I'll go a minute or two over, guys. I'm sorry. I need to get to the bottom of this. Make sure that everybody understands it.
Oh, I thought it was 3.
It wasn't the general and RTL model that I chose. Remember, I pointed out that activity coefficient models have a different model for liquid phase and vapor phase. General and RTL that I chose, which is the liquid phase, which is irrelevant in this problem. I didn't pay any attention, but at the same time I chose for the vapor phase the default, which was ideal gas. For ideal gas, there's no change in enthalpy, and let's quickly understand why. For ideal gas, what do I have? H, does it depend on pressure? No. For ideal gas, H is only a function of temperature. So the equation I have here is H hat at T1 equals H hat at T2. What does that mean for T2 in relationship to T1? And that's why we got 500, because we took ideal gas. So what I mastered is choosing, and until in reality what I was choosing was ideal gas. All right, now classes. What does it say? 447, okay. All right.